Hello students, welcome to our physics discussion. After the completion of Newton's laws, that is Newton's first law, Newton's second law and Newton's third law, we go to other implications. One can find connection of the so-called Newton's law. You know, the Newton's law, they are fundamental laws. And the Newton's law, they are also connected to other fundamental law. And here we consider one of the most fundamental laws of nature, that is conservation law, that is conservation of linear momentum. If you try to discuss it, that can be quite lengthy and that opens up a new topic. But initially, we have to be satisfied with the basics of it, and then we can elaborate that in our future discussions. As you know, so as Newton's second law is there, it says external net force will be equal to rate of change of momentum. I'm writing rate of change of momentum like this. Okay, that can be written as, or we may keep it as it is. We may not go for further elaboration. And you know, this force is the resultant force acting on the body or the external net force acting on the body. If by chance or if in a particular case external force acting on the body, net external force is zero, then immediately the left-hand side of this equation just vanishes. So that implies that delta P, the rate of change of momentum by delta T equal to 0. If you cross multiply it, then that implies delta P equal to 0. And when we say delta P equal to 0, what does it mean? What it should mean? Delta of something equal to 0 means, we know delta of something means change of that thing. If I say delta x equal to 0, that doesn't mean that x equal to 0. Strictly, you should not take that. That can make you go horribly wrong. When somebody says delta x equal to 0, that means x is not going through a change. Change in the x equal to 0. Change in the x is equal to 0 and x equal to 0, they are two completely different things. So similarly, we say change in the momentum equal to 0. That means momentum is not changing. That means momentum is constant. And sometimes people say that is also conserved. That is also conserved. The same thing, our books put it like this as the principle of conservation of linear momentum. That is principle of conservation of linear momentum. That says the momentum of a system remains conserved or remains constant if no net external force acts. The momentum of a system remains conserved or remains constant if no net external force acts. The thing that you have mentioned here, mathematically the same thing I have expressed in terms of language. If there is no external force acting on the body, no external net force acting on the body, then momentum is conserved or momentum is constant. That is known as principle of conservation of linear momentum. And that is one of the pillars on which physics rests in fact. There are maximum 6 to 7 pillars on which the physics rests, the entire physics rests. If one of them shakes or if one of them gets stray, then the entire thing doesn't take long to crumble down or to come down. So these conservational laws are like that. And this is one of the conservation laws, that is conservation of linear momentum. And that is one of the pillars on which physics rests. Okay, so thank you. Today, the law seems to be very simple, but if you go to the implication, how you are going to use that love, then that will be quite interesting, and that will be doing someday. Okay, thank you again.